Hello everyone, welcome to this session of class 9 mathematics, and I am your Anu from maxgoal.1. We are seeing continuously about chapter 7 triangles. We have finished SAS criterion, and we are going to start the next criterion, which is angle side angle congruence criterion. That is, we are going to compare two triangles, okay, according to the criterion angle side angle. That is, there are two angles, consider two angles and the side enclosed within those two angles. Just as we saw before, two sides, we considered two sides and the angle enclosed between them, isn't it? So this class will be seeing two angles and the side enclosed within it. So when we compare two triangles, see, for example, I have taken two triangles ABC and DEF for example, and we have angle B, angle E here, and angle C and angle F. So the corresponding angles, I have told you already, for two triangles to be congruent, we need to see the CPCT, that is corresponding parts of the corresponding triangles or the congruent triangles, isn't it? So there are 6 parts actually, three angles and 3 sides, isn't it? So it is just enough if we see 3 criterion, actually 3 parts. If the 3 parts are same or equal in both the triangles, we say those two triangles are congruent. So now we see angle B is equal to angle E and angle C is equal to angle F, and the side included within these two angles. Okay, so the side included within these two angles are also same. Then we can say that triangle ABC is congruent to triangle DEF. And the other thing I said was naming the triangles, and naming the triangles according in order is very important. See, I say triangle A B C. See, it goes in anti-clockwise direction, and triangles the same, D E F. So with the names, if I name the triangles in the proper way, in a correct order, both the triangles are named in the same order, then we can very well see from these two names we'll be able to get the angles which are equal and the side enclosed between them. See, I'll explain you how it is. See, if I say angle B, then the corresponding angle E has to be equal. Okay. Likewise, if I say angle C, then this C should be equal to angle F here, right? Then the side enclosed between them, that is B and CC. If B and C are the angles chosen, then the side included between them is BC. Likewise, if E and F are chosen, then the side enclosed within them is EF. Do you understand? So from the name, if the names are written in proper order, so from the names we'll be able to pick out the angles and the sides correspondingly. So that will be more easier for you. So as I said before, our aim whenever we are given with a question, our aim is to spot out two triangles. So the first thing is we need to spot out two triangles, and then we'll move on to the CPCTs. Okay. So we'll move on to the first problem. The diagonal AC of a quadrilateral. So quadrilateral is a 4-sided figure. Quadrilateral ABCD bisects the angles A and C. So the diagonal of the quadrilateral. See, the diagonal of the quadrilateral, one of the diagonals, that is AC. It bisects the angle A and C. So what do you mean by bisecting? It cuts into two equal halves. So this portion is equal to this. So I just name it as 1, 1, and this to be 2 and 2, because they are one and the same. Okay. Now what we need to do is prove that AB is equal to AD and CB is equal to CD. Okay, exactly. That is what we need to prove. AB is equal to AD and CB is equal to CD. Okay. So now what we are going to do is, so how can we prove that the sides are equal in a quadrilateral? Okay, because we don't know any other dimension of this quadrilateral. So how do we proceed? So first we know that this angle is equal to this angle and this angle is equal to this angle. This is what given here, right? Okay. So now our first aim is to spot two triangles, I said. So when I observe, I have a triangle here ABC, likewise ADC. Remember naming the triangles in correct order. So I have triangles ABC, triangle ABC, and next is triangle ADC, right? ABC and ADC, that is how we name them. Now what we have is, we have the angle. See, the two angles here are equal and these two angles are also equal because the diagonal bisect each other. Now what is given, we need to write it first, okay? So in these triangles, we see angle BAC, okay, angle BAC, how do I write? Angle BAC is equal to angle DAC. It is given. Why? Because the diagonal bisects, isn't it? So it is given. Now next is angle BCA. Okay, it is equal to angle DCA. So name it in a proper way. So this is also given because it is the bisected angle. Okay. Now consider the side between these two angles. The side AC. AC is equal to AC again because it is a common side for both the triangles, isn't it? It is a common side. AC, which is enclosed between these two angles, for those two triangles, that AC is common. So what we have two angles equal and the side enclosed between the angles to be equal. So according to what? According to ASA criterion. According to ASA criterion, we say that the triangle ABC is congruent to triangle ABC, isn't it? So from ASA criterion, we say that these two triangles are congruent, right? So according to CPCT, we know that corresponding parts of the congruent triangles are always equal, right? So from that, we say that AB is equal to AD. See, this AB is equal to AD. These two sides are equal, and CB is equal to CD. That is, CB is equal to CD because both the triangles are congruent according to ASA criteria. Do you understand? So that is how we find out, we prove that the sides, the corresponding sides are equal. So when you prove the two triangles are congruent, we can prove the corresponding parts of the congruent triangles are also equal. Now do you understand? This is a simpler problem we have taken first to understand the ASA criteria. So in the coming classes, we'll know much about, we'll understand much about the same criteria. Okay. Now take down. Now check the sum.